Hello everyone, welcome you all back to the virtual lab session. And our today's aim is to predetermine the voltage regulation of an alternator using open and short circuit test by EMF method. Now drag this experiment to the workspace and you can see the respective diagram of an open circuit test, below which the abbreviation and the ratings of a DC shunt motor and the alternator are given. And above, for both DC shunt motor and the field excitator, the power supply is given is DC, and here the DC shunt motor is coupled to the alternator, and the output from the alternator are open circuited, and there is no load is connected to the alternator output, and the field excitator is connected to the alternator by means of slip rings. Now let us see the procedure how it works. Close the DPST switch connecting the armature winding of the DC shunt motor. Between them, the rheostat is placed, which acts as a voltage divider, and by varying it, the voltage of the stator in DC shunt motor is varied. Now, by increasing the rheostat value, the current starts to flow through the DC shunt motor, and a mechanical output is given, which is coupled to the shaft of the rotor of an alternator. Bring the rated speed of an alternator by increasing the speed, the rheostat, and the rated speed of an alternator is 1500 rpm, which is given below. Now let increase the rheostat. Now the rated speed of the alternator is set. After that, close the DPST switch of the field excitated circuit, which is connected to the rotor of the through slip rings. Here in field excitated circuit, initially the voltage is 0, but at the output of the alternator here shows some voltage, that is due to some residual magnetism in the field winding. And now by varying the field excitated rheostat, we can check the graph between the output voltage and the field current until the rated voltage exceeds the rated until it exceeds the rated voltage. Set some value. Now start storing the data and give show data, and you can see the table here below. Likewise, we need to repeat it to 6 to 7 readings. Now we have taken several readings and we have stored the data. Now you can see several values. For this, we are going to draw a graph between the field current and the open circuit voltage. Generate graph to see the graph, and you can see the graph starts to increase when field current is the voltage starts to increase when the field current is increased.